in review publication. This would be a traditional review paper that can get updated. The second component is documentation of research artifacts via dataset-specific publications on Zenodo. Because here on Zenodo, this documentation could have a digital object identifier that can be linked. And the third component is a SQL database for exploring the link between the datasets and the research artifacts. And yeah, this is the framework. And you can also see here that we defined citation function that actually map the relation between the datasets and the research artifact. For example, this work here is introducing documentation for Chexpert, or these works here are extending Chexpert with either shortcuts or additional annotation. So our interactive demo is actually available on this link here, and we can share the link so you can access. I have here a short video to show how it looks like. And we are showing with different colors and different icons and color data sets and research artifacts. Here we zoom into Chexpert and we can see what is related. And when we clicked on the arrow, we can see the specific attributes for those works that are related to the dataset. And then besides having the full database, there is this option to choose a dataset. So these are research artifacts specifically for Chexpert. And again, we find some shortcuts and additional annotations. We can do the same for ISIC, that is a skin lesion dataset. And there is one more page where we find this MidCat taxonomy that we propose in a different work. And here the shortcuts are ordered based on this taxonomy. So these are examples of demographic shortcuts or co-founders. And we can also search for external co-founders of the datasets and research artifacts that are currently on the database. Yeah. So it is unrealistic to expect us to cover all areas of medical imaging, also to maintain an up-to-date living review and ensure that all researchers are aware of its existence. We therefore propose a structure that promotes collaboration and with contributions from the community. And we currently foresee a limitation of our proposal, and is that we do not yet integrate any mechanism for quality assessment, such as a data steward who could monitor the accuracy of the contribution. So maybe you are still not convinced of why we need a living review for medical imaging. So to better understand its importance, I will go through some details about the dataset creation process, annotation, data sharing, and maintenance. So I think the first step when we are trying to create a dataset is that we need to translate the clinical problem into a machine learning problem. And for this, we need to align expectations among multidisciplinary stakeholders while also establishing a utility criterion. And this could be, for example, the reduction of workload of the radiology department. Then the next step would be we need to decide whether we want to collect new data or if we are going to do a retrospective study, and for the particular problem or task, how much data we need to collect. Then the next step would be to design the labeling process and identify potential risk where biases could be introduced. And one thing is important is that this labeling process will also have an impact on data quality. So for example, there might be epistemic differences, like the word here, opacity in chest X-rays, might have different meanings across countries or might lack a translation to a specific language. So we think that the living review could help researchers to better understand the decisions made throughout the dataset creation process. Then labeling tasks in medical imaging depend on the context of the disease. the task itself, if we are targeting classification or segmentation, and how the target labels are acquired. For example, ground truth labels for lesions or nodules could be confirmed via biopsies, while other labels or annotations could be based on the interpretation of the expert or other annotators. So we discuss two important considerations which vary with the task, that are inter-observer variability and expertise cost trade-off. So establishing observer variability of the task at hand is crucial before data collection because it helps to set accuracy targets, determine the required number of annotators, estimate the needed data, and assess the variability. Observer variability is then measured by having multiple annotators curating a small set of representative examples and calculating their agreement for binary classifications or metric like DICE score for segmentation. And then this observer variability also varies greatly according to the task, anatomical structure, and their sizes, image type, and expertise level. So we will expect low variability for healthy large organs, like for example the lungs or the heart, while we will expect larger variability for small structures, like for example lung nodules. And also, observer variability will be influenced by inconsistent training across institutions and insufficient guidelines for annotations. Then going back to the second point, that is expertise cost trade-off. Here, selecting the right annotator for a task is also a crucial consideration. And domain expertise will vary from clinicians to layperson because for some tasks, for example, to detect surgical instruments in laparoscopic images, laypersons could annotate the images without the need of a clinician. And there has been several successful results also with crowdsourced annotation. However, in many cases, missing details about the annotation process. So despite the apparent advantages of crowdsourcing here, we still highlight that there is still a lot of hidden data work. Another type of approaches here are semi-automatic. For example, some people creating datasets have leveraged natural language processing to extract diagnostics label from unstructured clinical reports, but this strategy have been shown to introduce labeling errors. So I'm showing an example figure here of images that are labeled as no finding. And something that can happen often is that if the report says no change from previous, the NLP would label this image as no finding. However, the image could be labeled as could have this no change from previous because it's a follow-up image. But this doesn't mean that there is no pathology. So in the image, there are some examples with red boxes of images that actually contain pathologies or others that contain support devices. And another type of approaches are hybrid approaches that are based on active learning, label corrections, and hard sample mining. And in this case, hard sample mining consists of collecting additional hard samples that could be from specific device manufacturers or rare disease subtypes. And here we could combine like the advantages of both, that is like having human annotations, but also automated methods. And here we highlight also an example or a difference between academic setups and industry, where in industry, usually this relabeling process is done with domain experts. So datasets may be more dynamic, but at the same time, their proprietary nature complicates analyzing this cost versus quality trade-off. So to close this part, we again highlight the benefits of the living review. That is that we could have linked the documentation of the annotation process, consisting of both the annotation guidelines and also the annotation. This documentation could reflect this observer variability and also the trade-off between annotator expertise and cost. Then we looked further inside the datasets, and we actually analyzed 4 different case studies. And the first one is chest X-rays. So for the datasets that we looked about chest X-rays that are the most commonly used, they often include information like age, gender, or sex, while self-reported race is usually rare. We find that age is skewed towards older population, like patients of around 60 years old. And we've already highlighted these studies that show that there are performance disparities regarding gender or racial groups. And yes, I just mentioned before, regarding annotations, many times we consider that the annotations that are in a dataset are ground truth, but we need to consider if these annotations are coming from experienced radiologists or they were automatically extracted with NLP and so on. For skin lesions, we've already mentioned before ISIC, that is a big data set that has been hosted in Grand Challenges. And about demographics, we highlight here that there are some more recent data sets like PAT-UFES or this one here, that now they introduce also information about skin type, genetic background, and so on. And we also find inside this data, not these data sets, but ISIC examples of shortcuts. So in this image here, you can see dark corners, also the presence of hair, patches, and so on. And this could be related to either benign or malignant, also like producing this shortcut. The third example is fetal ultrasound, and here we worry that for the most commonly used fetal ultrasound dataset, there are actually non-demographics reported for these datasets, which we find very concerning. And something that we discuss in our manuscript is also how ultrasound is a very challenging modality, and the experience of the sonographer also affects the image quality. So this is also something that should be reflected. And our last example is about brain MRI and neuroimaging. Here, for example, regarding demographics, we find that these US studies between 2010 and 20, they report sex in 77% of the cases, but only 10% report race and 4% report ethnicity, which is pretty low. And here we also wanted to highlight as positive initiative recently to diversify current datasets, the inclusion of a dataset for children and one for sub-Saharan African populations into the BRATS dataset. So again, coming back to the link with our living review, the living review could provide a way of better documenting the study design, also an improved analysis, including all the demographics, and it also allows for the expansion of datasets with new annotations of metadata, but also errors, shortcuts, and so on. And the last part I wanted to talk about is the full data lifecycle. So for effective research data management is crucial for reproducibility and also reusability. So for this, we need to consider the full data lifecycle because data should comply with these FAIR principles here. So we need to take into account data from the acquisition, then the description, storage, sharing, and also maintenance that many people forget about. So converting to established data standards directly after acquisition ensures transparency and provenance. And this might consist of adding metadata and performing some additional annotation when we are trying to describe the data and organize it properly into the standard. And the documentation of where, how the metadata and annotations were acquired is also important to ensure the usefulness. And then very important regarding sharing data via repositories. is that whenever a dataset is updated or changed, it should be versioned and the changes should be documented. While this functionality is available in some data platforms, it's not widely adopted. For example, Hugging Face provides a way to track the history of files, but it does not explicitly version their dataset. And we've already mentioned about this, but on Kaggle, we found on this work many copies of datasets, which are usually missing documentation or missing the details about preprocessing, provenance, license, and so on. So here, coming back to the case study about neuroimaging, we can highlight, or we are inspired by the neuroimaging community because they are an example of good scientific practices. They have clear standards for data, like these bits standards, sorry. Also, they have standards for preprocessing, for converting images from DICOM to Nifty format, and they even have data sharing platforms and tools like DataLab and OpenNeural. So our framework then incentivizes researchers to adopt better dataset management practices. We recommend using persistent identifiers and storing, also versioning the datasets for reproducibility of the results, and also providing license and proper tracking for author attribution. Yeah, so I will close here saying that our living review then aims to keep track about datasets and the research artifact. It also encourages collaborative research, better dataset documentation and citation practices, and regular updates on new evidence. And then I would like to just thank all the participants of the webinar series, also all the co-authors of this work. Also, thank you to the funders for the funding for the project and also the workshop. Yeah, thank you for your attention and looking forward to questions.
Thank you very much, Amelia. So we have some minutes for questions. I think we're a little bit ahead of time even. If you have any questions, you're welcome to type either in the chat or you can raise your hand in Zoom, and I can try to figure out how to unmute you. So maybe to start, Amelia, how do you see maybe that the process would work? So you mentioned in the beginning that well, we as the group that worked on this, we probably would not be able to do everything ourselves. Can you comment on how you would see this?
Yeah. So I think we are happy also to take suggestions on how to do this during the webinar. I guess one tool, or at least we've discussed or we've thought about two options. One option would be to have some GitHub database where people could do pull requests about what do they want to include. But this wouldn't be completely automatic. Another option would be to have some kind of Google Outlook form where people could as well explain like what is their research artifact that they want to contribute for a dataset. But this we would need to find a way also to distribute it so that it's not only us having that kind of the data steward role that we need to approve every single contribution.
Thanks. Yeah, actually, I just thought about, I think there's a MICAI special interest group a bit related to these topics, so maybe we could have a look at that. Are there any other questions from the audience? Do you know already if you are doing a presentation or a poster at FACT?
No, I don't, but I didn't receive information about posters, so I will see.
Okay, so if there are no more questions, we can continue with our program.
Yeah,
Let me
thanks.
share my slide again. So let's thank Amelia again. I think this should work.